Now we're going to look at the graphs of tangent and cotangent. So I didn't go through the process of making the table of values for these. You could do that. But what I did instead was just kind of give us the pictures of the base graphs. Okay. So these do also have, they repeat, they have cycles. So this is one cycle. And then if you were to see the graph over a larger interval, you would see this same shape just repeated over and over again. So let's start with tan x. The sort of standard period that we look at is centered around the origin. It goes from negative pi over 2 to pi over 2 where there are asymptotes. So these are vertical asymptotes. And it has the shape, it kind of reminds you of an x cubed curve, right? Similar shape. You could see the beginning of the next one, it would have just gone right here. And the key points that we talk about for this one, the first one is this asymptote. So it starts off with an asymptote, and that's at negative pi over 2. At negative pi over 4, the tangent is negative 1. So that's kind of our second point of interest. At the 0, it's 0, so it's 0 in the middle. At pi over 4, it's 1. And then the last point would be the second asymptote that closes off the period or the cycle at pi over 2. So you still have 5 points of interest, similar to sine and cosine, but in this case with tangent, it starts with an asymptote, ends with an asymptote. In the middle, it's 0 or hits that midline. And then it's down 1 on the left and up 1 on the right for the other 2 points. And then you can draw in that shape. So that's kind of the way I see that base graph. We can answer some questions about it. Okay. So you'll note that tangent, just like secant and cosecant, is undefined in several places. If you remember, tangent is equal to sine over cosine. We talked about that in a previous lesson. And so it's going to be undefined at any point where cosine is 0. And remember, cosine hit that x-axis at all those k pi over 2 where k was odd. So the domain of tangent will be all reals except those points. X equals k pi over 2, and k is an odd integer. All right, well, look at the picture. What do you see as the range of tangent? If that's the domain, that's what I can plug in. What kind of values are you getting out? So unlike sine and cosine, tangent goes all the way from down here to up here. It covers all of the y values. So the range of tangent is going to be all reals. And what about its period? If it starts this cycle at pi over 2, I'm sorry, negative pi over 2 and ends it at pi over 2, what's the total distance there? You got half a pi here and half a pi there. You put those together and you get 1 whole pi. So the period for tangent is different than the period for sine and cosine, right? It's half. It's not 2 pi, it's pi. All right, kind of doing the same sort of analysis for cotangent. Cotangent now has a similar shape, but it's going the other way. So it's sort of the starts at the top and shifts to down instead of starts down and shifts up. It still does start with an asymptote here. That is at 0. It ends in an asymptote at pi. It's pi. And again, it hits 0 in the middle at pi over 2. It is 1 at pi over 4 and negative 1 at 3 pi over 4. So very similar 5 points of interest. 5 points that will allow you to move this graph up, down, left, right, stretch it, etc. Okay. So in this case, it starts with the asymptote at 0. You'll notice that's a different starting point. Tangent, its period is centered around 0. So it goes from negative pi over 2 to pi over 2. Whereas cotangent starts at 0 and ends at pi. So it also has a period of pi, but starts at 0, ends at pi. So it hits the middle, the 0 at pi over 2. And then it's just in reverse. Tangent was down 1 on the left, up 1 on the right. Cotangent is up 1 on the left, down 1 on the right. Okay, and a couple of observations. If tangent is sine over cosine, then cotangent is cosine over sine. So that means it's undefined anywhere where sine x equals 0. And that gives us a domain of all reals except where x equals k pi. K is any integer in this case. 1, 2, 3, 4, 0 even. The range is the same and the period is the same. So for tangent and cotangent, they're hitting all of those y values and they're clocking one cycle in a distance of pi. So when you go to grade graph these, the main idea is going to be to find that the period if it's adjusting, to shift the two beginning and end asymptotes if it does need to shift left or right. Move your midline up or down so that you can get that middle point on the correct spot. And then if it stretches at all, instead of going up 1, down 1, you'll go up 2 or up 3 or down 3. So these are the 2 points, the 1 and the -1, 1 and -1 that you can use to stretch. So let's go ahead and graph a couple of examples. We're going to graph at least one period of this one here. So we don't really say that there's an amplitude for tangent or cotangent because there is no top and bottom of the graph. So it doesn't make sense to say amplitude is 2. Instead, what I'm just going to say is stretch. Stretch by 2. And then that is going to be taken care of, like I said, by those 2 points that were usually 1 and -1. Now they're going to be 2 and -2. Okay. Now we have a number in front of the x. Remember how for sine and cosine we said the period would be 2 pi, its usual period, divided by 1/2. So for tangent and cotangent, the period will be the same idea, but since the original period is pi, then you're going to divide pi by that number in front of the x. So it is the case for all of them that the period will be determined by dividing the original period of that function by the coefficient of x. So in this case, that will be pi over 1/2, which is pi times 2, so 2 pi. And that looks like that's the only changes for this particular one. There's no adding or subtracting, up, down, left, right. So if I were to draw a couple of axes here. Since I'm not going to change this up, down, left, or right, remember tangent is centered around the origin. So that middle, it will stay here at 0, 0 in the middle. And so if I need to go a distance of 2 pi, that means I'm going to have to go pi on this side and pi on that side. So the total is 2 pi. And that will allow me to put in my asymptotes. And then halfway in between there would be my negative pi over 2 or my pi over 2. That's what would usually be up at 1. But in this case, because we have to stretch it by 2, with this 2 here, I would go down 2 on the left and up 2 on the right. So my curve is going to be a little bit more flattened than it was in the original period of pi, of tangent. Okay, so not too painful. Let's try one more. Let's do 3 cotangent of 1/4 x. So same thing, I'm going to look at this 3 here and understand that that is a stretch factor. And then my period, these are the only 2 adjustments that I have, would be pi over 1/4. So that would be 4 times pi. The difference on cotangent is that it isn't centered around the origin. Remember, it starts at 0. Started its cycle at 0. And so if I'm not moving left, right, then it's still going to start at 0, but it's going to go all the way out here to 4 pi as its end. So I can kind of just do my midpoint and my other 2 midpoints, and it's just going to go 1, 2, 3, 4 pi. And so I'll have an asymptote. It's hard to draw an asymptote on an axis here and here. And my middle will still cross the x-axis. So then for cotangent, I would usually go up 1 on the left, down 1 on the right, but I need to go up 3. So up 3, down 3. So again, it's a more stretched out graph when you do the multiply by a number in front. All right, and that's graphing tangent and cotangent.